Cosine law.
Right. And the trick is this, all right? You're either going to be using SOHCAHTOA, which is when you have a 90 degrees, or when you don't have 90 degrees, you're going to be using one of these. And the main question is, how do you know which one to use, okay? Here, let's look at a reference sheet here, and then this will tell you exactly when to use which one. So sine law, yeah, sine law, the one on the top here, you'd use when you have a pair, okay? Like you see here, there's this and this, that's a pair, right? And over here, we don't have any pairs if you look at this, but this is just a trick. If you know two angles, you automatically know the third angle. That gives you a pair, and that gives you a pair, okay? So when you have a pair, you use the sine law. Cosine law, you use when you have something like this, like a smaller triangle within the triangle. Side, angle, side. You see this? And then the other condition is when you have all the three sides, but you don't have the angle. That's also a cosine law question. I'm gonna keep this here. Maybe it'll help. I'm gonna keep this. All right, let's try and do some questions. The very first question here says, how do we find the missing thing? So in 1a, the angle is missing, yeah? This angle A is missing. What do? We do use the sine law or the cosine law?
The sine law.
All right, so how do we set this up?
Um, 3.1 over sine A.
Yeah, that's equals to
2.7 over sine 60.
Yes, that's correct. Now, in this, the unknown is in the denominator. How do we solve this for A?
You multiply by sine A first.
Yes, correct. So you get 3.1 equals, again, this bit, we can plug this in a calculator. What's 2.7 divided by sine 60? So that's just 3.1, and then you have sine A. It's actually 3.117. And then?
You divide?
Yes, you divide both sides by 3.117, right? So, and that gives me 0.994 equals sine A. What about now?
You do the second function.
Correct. You do the second sine inverse of this, and that gives you 84 degrees, and A is 84, and you're done. Alrighty? Easy as that. Look at B. What's the approach here? We're trying to find this C, letter C. Any ideas?
Sine law?
No, not sine law. There's a right angle here, you see? That angle B is 90 degrees. So when there's a right angle, you want to use SOHCAHTOA. Okay? Sine law and cosine law are strictly when it's a non-right angle triangle. So if there's a right angle triangle, you can straight up use SOHCAHTOA. So we're trying to find C, yeah? Relative to this angle, is that the opposite or the adjacent?
Opposite.
Yeah, so opposite is C, adjacent is 1.8, hypotenuse we don't know, we don't care. So sine, cos, or tan?
Tan.
Yes, so tan of 47, yeah? That's equals to the opposite, which is C, divided by the adjacent of 1.8. How do we solve this equation for C?
You multiply by 1.8.
Correct. So tan 47 times 1.8, and that will give you C is 1.93, and you're done. Look at C. SOHCAHTOA, sine law, or cosine law?
Sine law?
No, not sine law, because you need to know a pair, right? You need to know a pair. So we know the side, but we don't know the angle. That's not a pair.
Oh.
Okay, like this would be a sine law because we have a pair. We know they're both knowns. Here we don't have a pair. So it won't be the sine law. Yeah, we don't have any of the three pairs, you see? We don't know this angle. We don't know this angle. We don't know that angle either. So that's a cosine law problem, okay?
Mm-hmm.
So what's missing? A, B, or C? Or I mean, this is angle A, right? So we're gonna be using this. The first one up there, okay? They're all the same. It just depends on which side is missing. So let's set this up. This is gonna be A, this is gonna be B, and this is gonna be C. And we're using the first formula up here. So that says A squared, so 2 squared is equals to 3 squared plus 2.9 squared minus 2 times all these guys in cosine of A. There we go. How do we solve this for A? If you remember.
First, you square them all.
Yeah, let's do that. So 4, and I can just add this bit. 3 squared plus 2.9 squared, that'll be 17.41. And then I can also plug that in. 2 times 3 times 2.9. So that'll be 17.4 cosine A. Now what?
You would subtract 17.41.
That's correct. So 4 minus 17.41, and then you would divide, right?
Mm-hmm.
And then you just do cos inverse of whatever you get, and that gives us A is 40 degrees. And there we go. So these are the three, I mean, that's basically it. That's the whole unit. I'm going to be using either the sine law, cosine law, or a combination, or using SOHCAHTOA to solve anything they throw at you. Let me just pull this up, I guess, one thing at a time. Number 4. Actually, they've already given us a diagram, so maybe we don't even need the words. Let's just use this. So here, we're trying to find this missing side, okay? The one with a question mark on it. We can just put some labels on this. Forget the O. Let's call this A, B, and C. Okay?
Mm-hmm.
So the unknown is the small letter A, this is small letter B, this is small letter C. Sine law or cosine law? It's obviously not SOHCAHTOA because there's no right angle that we know of. So the question is this a sine law problem or cosine law? It's very simple. You can just ask yourself, do we know a pair? Are any of the pairs known?
No.
No, right? So we have the angle, but we don't have the opposite side. We don't have the angle, we don't have the angle. So no pairs are known. That's automatically cosine law. Cool?
Mm-hmm.
And again, in this one, A is missing. So let's set this up. A squared is equals to B squared plus C squared minus 2 times 4 times 5 times cosine of 30. Like that.
Mm-hmm.
How do we solve this for A? Now
You
notice,
square them and
so this one you can just plug it in a calculator because the unknown is on the left side. It's already set up nicely for us. So just plug it in. Why don't you try this? Plug the right hand side of this on your calculator in one step. It should give you something. Did you get anything?
is it 6.35?
That's perfect. That's exactly what it is. But notice that's A squared, right?
Mm-hmm.
How do we find A if this is A squared?
Do you square root it?
Correct. You just square root it. That's not linear, but the step is very simple. You just square root it. That's something called a quadratic because it's power of 2. linear is strictly power of 1, but doesn't change much. You just square root it and you are done, okay? Easy as that. Yeah, once you crack the code of knowing which one to use, it's just a matter of plugging things in. But it's not always going to be easy though, especially when they don't give you a diagram, like in this question. So this operator discovers a ship on the ocean floor. Right, so here's our guy, and well, radar works like this. Okay, it just kind of throws a wave, and then if it touches something, it bounces back. So you know something is down there. It's like a bat, like an echo. So from this point, he notices the sunken ship, which is 200 meters below. Okay. The radar operator measures the angle of depression to the front and back. All right, so let's say, what's going on here? This is the ship. He measures it to the front, and then he also measures it to the back. Now a question for you. Angle of depression. Is it going to be the one on the outside or the one on the inside?
Inside.
No, angle of depression is what? Always from the line of sight, okay? It's from the horizontal. You see, this is our line of sight. This will be our elevation. This would be our depression. It's always from the horizontal. So it's going to be the one on the outside. Okay? So this one is 56 and the other one is 62. And the question is, how long is the ship? So we're supposed to find this distance. What's the approach here? So you have to do some work before you can, before you even know which one to use. If this is 56, where else in this triangle is 56? Use the Z rule, okay? You see, if this is something, this is equals to this. Same thing from the other side. If this is something, then if these two lines are parallel, then this angle will be the same. So the question is, if this is 56, where in this triangle is 56?
The bottom left.
Yes, so this is 56, and then automatically this would be 62, yeah? And again, this is vertically downward, so they're both 90 degrees. Now, how do we find the base of the triangle?
Wait, could you find like the angle at the top?
This one? Yeah, that'll be 180 minus both of these.
So 62?
Is that what you got? Minus 56 minus 62, yeah, 62. Now what? No. All right, so whenever there's a 90 degrees, it's SOHCAHTOA. Keep that in mind, all right? What we're gonna do is we're gonna cut this in half. We're gonna first find this, and we're gonna find this, and then we're gonna add them up and we get X. Let's look at the triangle on the left. Relative to that angle 56, which two sides are we interested in? We know the opposite is 200, yeah? Are we interested in the hypotenuse or the adjacent?
The adjacent?
Right, adjacent equals what? So is it sine, cos, or tan?
Tan.
Exactly. So we have tan 56 is equals to the opposite divided by the adjacent. Okay. And it's going to be the exact same thing on the other triangle. The opposite is still 200. We're still interested in the other second adjacent here, but now the angle is 62 degrees, right? And this is from the triangle on the right, and this is on the left. Now notice the unknown is in the denominator. How do we solve this equation? This one
Do
is
we
a linear.
multiply by tan 56?
No, that won't help you. No, not multiple. What do we do when the unknown is in the denominator? We always multiply by the unknown on both sides, okay? So that we bring it up in the numerator. Multiplying by tan 56 won't help. Multiply by a on both sides, because if you do that, you see on this side it cancels out, and then you can just divide by tan 56 to find the a, right? If the unknown is in the denominator, always multiply by the unknown on both sides. Similarly, on the other side, we do the same thing. It's going to be 200 divided by tan 62, and that is 106.34. Okay? These are the adjacents, and then we just sum them up, plus, therefore, the total length of the ship that sank was 241.24 meters. Okay? And there we go. That's how we can solve a problem like this. So for example, you know there's a ship down there, yeah? But you don't know which ship it was. But if you know, I mean, there's records of any ship ever made. So for example, you find a ship on the bottom of the ocean, but you don't know which one it is. You can kind of use maths and compare it, right? So we know this is the length of the ship. So we can kind of compare it to what we know, and we will know exactly which ship that is. Doesn't always work though. This is only in modern times. A lot of the ships that are on the bottom of the ocean are older ships, you know, before technology. So yeah, we don't have a lot of knowledge about that, but the modern ones, we will be able to find out exactly which one it is. That's one of the uses. I mean, that's one of the many uses of trig. Right, so let's try another one. All right, let's look at this one. This one kind of uses a little bit of physics, or navigation, in fact, not physics per se, but let's try this. So there are two ships. We'll just call them A and B. Looks like Spanish names. And what's happening here? They're 50 kilometers apart. The first ship is, what does this mean? Ever seen anything like this?
I think.
So what that means is if you've seen a compass, it works like this, like there's north, east, southwest. So north 45 degrees west means you first go north, okay? And then you turn 45 degrees in this direction, in the west direction. You see that? So what that means for us is that here's our ship B, and the other ship is in this direction. Okay? And this is 45 degrees. And here's our A, ship A, and the distance between them was given, that's 50 kilometers. Cool? The first ship sights a distress flare at south 5 degrees east. Now, where is that? South 5 degrees east means, again, you go south first, okay? And then you go 5 degrees east. So like there. Cool? Let me just put this, I know I need some space. So we know the distance between them is 50. So let's say here's the distress. And from this guy, he notices it at, so this angle will be 5. And the other one does south 50 degrees west. So actually he's gonna be further down. Let's do this one first. South 50 degrees west means this way. You first go south and then you go. So this is the distress signal. Let's just call it C. There's a lot happening in this diagram. So this angle down here is 50. And from this one, this angle is 5. All right, this question is gonna be not easy. The question is, what's the distance of this? How far is each ship from the distress signal? So we're looking to find this side length, and we're also looking to find this side length. Alrighty, any ideas on how to do this?
No.
Absolutely no clue, right? Let's find this angle first. We know up is 45, down is 50. What would that angle be? It'll be 180 minus, right?
Mm-hmm.
180 minus 45 minus 50. So 180 minus 45 minus 50. So that's 85 degrees on the inside, okay?
Uh-huh.
Now we just need one more angle. You see this is 5?
Mm-hmm.
What would this angle be?
5.
Yes. Okay.
Mm-hmm.
Now let's look at this. That's just mumbo jumbo there, but I can clean it up here. So we're trying to find this length, okay? And we're trying to find this length. We know this is 50, we know this is 5, we know this is 85. Can we solve this?
You could use sine law.
Yes, perfect. So this is A, this is C, and that's B. So it's gonna be 50 over sine of 5, yeah?
Mm-hmm.
That is equals to C over sine of 85. And multiply both sides by sine 85 and you'll have the answer. Sine 5 times sine 85. And that is going to be 571 kilometers. And using the same thing, you can find what A is. Once you have the triangle, it's pretty simple, yeah, but the hardest part is coming up with the triangle.
Mm-hmm.
So that's how you read the angles, okay? North 45 west means you first go west and then go north. Or the other way around, you north 45 degrees west means you go north and then 45 degrees in the west direction. Now this one is an angle of elevation question. So we have two people, Fred and Agnes. So here's Fred, here's Agnes, and they are 520 meters apart. As Brendan, so there's someone, Brendan flies overhead in an airplane, they measure the angle of elevation. So now the question to you, is the angle of elevation the angle on the outside or the angle on the inside?
Outside.
No, it's the angle on the inside. It's always from the horizontal, right? Look at this. This is the angle of elevation. This is the angle of depression. It's always from the horizontal. Okay, you see the horizontal line here?
Mm-hmm.
Either go up from that or you go down from that. So angle of elevation will be this one, the one on the inside here. Okay?
Okay.
So this one is whatever it is, 63. And for the other person, it's 36. And the question is, what is the height of the airplane? So we're trying to find side length BC. The altitude, basically, the height of the triangle.
Could you just do like one part of the triangle?
No, we can't do one part of the triangle because we don't know. We know the total distance between them is 520. We don't know if that's chopped in half. Probably not.
Oh.
You gotta use what? You gotta use the whole triangle, all right? The big triangle. The whole big triangle. Look at that. We know two sides of two angles, right? 63 and 36. What's gonna be the angle up here?
81.
Yes, 81. Now what are we looking for? We're looking for the height of the triangle, right?
Mm-hmm.
So to do this, you can find the hypotenuse using sine law, and then you can just use SOHCAHTOA. You see it? We'll first use, because we have a pair now, 81 and 520. We can use that, and we can use maybe 36 and this side to find this side, yeah?
Mm-hmm.
The hypotenuse of any one triangle, and then you can just use SOHCAHTOA from there. Okay? It'll look like this. So we have 520 over sine of 81. That's equals to what over what?
B over sine B.
So we can just call this BF, okay? BF
Mm-hmm.
over what? Sine of what? What's the opposite angle to this? Look at the bigger picture, okay? Look at the bigger triangle. 36, right? Because BF is opposite here. No?
Mm-hmm.
You could have also done BA over sine 63. Okay? BA over sine 63. Because then you would be looking this way, but the idea is the same. Once you find the hypotenuse, you can just use SOHCAHTOA. So now we're going to multiply both sides by sine 36. 520 divided by sine 81 times sine 36. So BF, the hypotenuse of the left triangle, is 309. Now, using this information, can we find the height? Can we find BC? What do you think?
Yes.
Okay, what's the idea? How do we set this up?
Do you use sine?
Yes. Yes. Sine 63, yeah,
Mm-hmm.
is equals to what over what?
Um,
Again, we're
you
looking
know
at
what goes on top?
yeah, BC, okay, BC, this side,
Mm-hmm.
over what?
The hypotenuse.
Right, which is 309, yeah? So how do
Mm-hmm.
we solve this equation for BC?
You multiply by the denominator.
Correct. So 309 times sine 63 is the answer to this, 275 meters, okay?
Mm-hmm.
That's not very high for a plane, but there we go. That makes sense?
Uh-huh.
So yeah, sometimes you gotta look at the bigger picture, especially when there's multiple triangles involved. Look at the bigger picture, and that should make things a little bit easier. And let's try doing another one of these physics problem, I guess, because let's kill this. So let's look at this. So another radar question. So it shows two planes that are at the same altitude. That means they have the same height, okay, from the ground. Let's say this is plane A, let's say this is plane B. According to the rangefinder, one airplane is 100 kilometers away in the direction of north 60 degrees east. So let's say the range finder is somewhere here. Actually, let's first identify where north 60 degrees east is. So that means first you go north, okay? You go north, and then from that position, you go 60 degrees towards the east side. Okay? So this distance is going to be 100 degrees, and this is the rangefinder. Cool? What about the other one? The other one says the other airplane is 160 kilometers away in the direction of south 50 degrees east. Now, what is south 50 degrees east? Where do we go first? Or sorry, south 50, yeah. Where do we go first for this one?
South?
Yes, you go south first, right? You go south first, and then you go 50 degrees this way, yeah? So actually B is not gonna be there. B is gonna be somewhere here. So from this position, this is the vertical. This angle is 50, and airplane B is here, like that. And we do know the distances. We know this one is 100, and we know what's the other distance? 160. Let me just erase this. And we know this distance is 160. The question is, what's this distance? Any ideas on how to do this? Now that we have the triangle, it's pretty straightforward if you just figure out which law to use. Step one, I mean, you have these two angles. Let's find the angle in the middle. What will that be?
70?
Yes. 70. Okay. Now do you see it? Sine law or cosine law? Ask yourself, do we know any pairs? Are any of the pairs known?
No.
No, it's not. So what law is it?
Cosine?
Exactly, it's gonna be the cosine law, right? So let's set this up. We're looking for the distance between A and B, which is opposite from angle C, so let's call that C. So C squared is equals to A squared plus B squared minus 2 times the whole shebang. We're using the third one, okay? Times cosine of 70. Cool? So let's try it. 100 squared plus 160 squared minus 2 times 100 times 160 times cosine of 70. And that gives us a big number, 24655. That's C squared. How do we find C?
You square root the number?
Right, you square root the number. So that's going to be 157 kilometers. And there we go. They're 157 kilometers apart, plane A and B. Cool. So that's the answer to part A. Look at part B. It says the airplanes are approaching at the same speed. Which plane will arrive first? It's basically asking us, is this side length bigger or is this side length bigger? Okay. See, this is only 100 kilometers away, right? This is 160 kilometers away. They're traveling at the same speed. So the one that's closer is gonna probably get there faster. So A would get there faster because it has less distance to travel.
Uh-huh.
Does that make sense?
Mm-hmm.
All right, let me just clean this up. Let's try doing this one. In a parallelogram, right? So we know what a parallelogram is, right? It's basically a curved rectangle or a rectangle at an angle. So let's say that's a parallelogram, two adjacent sides. So this is 10, well, this is gonna be 10, and this is 12. The shorter diagonal is 15 centimeters. So A, B, C, D. Is AC 15 or is BD 15?
BD.
BD would be longer, right? BD is gonna be longer than AC because if you look at where B starts here, and then D is all the way here, yeah?
Uh-huh.
And whereas A starts here and C ends here. So AC is definitely shorter than BD. So this would be the shorter diagonal, and this is 15.
Mm-hmm.
Determine to the nearest degree the measure of all four angles. Alrighty, so in this case, we don't know any of the angles. Which law do we use? And which angle should we find, actually, to help us? What do you think?
Um,
Here, I'll give you a hint, okay? In a parallelogram, okay? In a parallelogram, this angle and this angle, they add up to 180 degrees.
so you could just find B.
Yes, you could just find B and you basically have everything else, right?
What about A and C?
So if you have B, yeah, the other
Mhm.
one would be 180 minus that, and A and C is gonna be the same thing. We're not interested in the small one, we're interested in the big angles, yeah?
Uh-huh.
That angle is the same thing as this.
Mm-hmm.
So once we have one, we basically have all four. Okay?
Oh, okay.
How do we find angle B?
Um,
Sine law or cosine law?
cosine.
Correct. Let's set this up. We're going to be using this one, okay? So B squared, again, B is this. We can call this A, and then this is small c. So B squared is equals to A squared 10 squared plus C squared minus 2 times 10 times 12. Yeah? So we
Mm-hmm.
also know what B is, right? B is 15. Yeah, B is 15 squared, and then times cosine of B. There we go. How do you solve this equation for B? Now here the angle's missing, okay?
Um, you square the first numbers and then add them.
Right, you could subtract them, I guess. So that's going to be 15 squared minus 10 squared minus 12 squared. That'll be negative 19 is equals to negative 2 times 10 times 12. Negative 240 cosine B. There we go. Now what?
You divide.
Correct. So negative 19 divided by that. And then? What do we do after dividing?
You use the second function?
Yes, so second cos inverse, that's called, okay? And that's 86 degrees. So angle B is 86. Cool. That means, again, actually they're going to be equal. This and this angle is going to be equal. So that means D is also 86. Okay. That means C and A will be 180 minus that. 180 minus 86. What's that? 94. And there we go. That's what A and C will be.
Okay.
Once you have one angle in a parallelogram, you basically have everything else. Buy one, get one free kind of an offer. Or buy one, get three free, in fact. Let's try to do another plane question, but this one doesn't have the navigation stuff. This is just a straightforward one, it looks like. Two planes leave an airport at the same time. One plane travels at this speed, the other plane travels at this speed. About 2 hours later, they are 800 kilometers apart. Determine the angle between their paths. So this is what happened. We have one plane going this way. We have one plane going this way. And after 2 hours, they are 800 kilometers apart. And we're trying to find this angle here, angle C. What's the
You
approach?
just like multiply 355 by 2?
Yes, that's exactly what you do. So this will be 900, and what's that? 350 times 2 is 700, so that should be 710, right? Like this. What now?
Do you use cosine?
Yes, you do. So what's which cosine? First, second, or third?
Third?
Correct. So you just set this up, right? So C squared, so 800 squared. From here, it's just a matter of plugging things in the calculator. Minus 2 times 710 times 900 times cosine of C, yeah? So you move these to the other side, and then you divide by this, and then you do second function. And you'll get the answer in 3 steps on the calculator. We don't have to do it, we've already done this a couple of times. The main idea here is to set up the triangle, I guess. Let's try this one. From the top of a 8-meter house, the angle of elevation to the top of a flag, again, there's a diagram is given. How tall is the flagpole? So we're basically trying to find this, the height of this. What's the approach here? What's the plan of attack? We're trying to find the height.
Add like the 22 and 9?
Yeah, sure you can. That'll give you whatever, 31. The whole thing is going to be 31. But how does that help us? We don't know any of the sides of that triangle.
Could you use like the Z rule for like the 22 degrees?
Yeah, so which would be 22?
Like the second corner?
Down here?
Mm-hmm.
That's correct. Now what? If that's 22, what's the angle here?
$68.
Correct. And once we have 68, 31, we can also find this angle up there, right? 180 minus 31 minus 68, and that'll be 81 degrees. Okay, so we know all three angles. We just need to find one side length, and then we can find the height of the pole. Which do we attack? Which side length?
Wait, would like the other side also be 8 meters?
Yeah, up
Like
until
the
here.
side of it?
It would be, yeah. Like up until here. But that doesn't help us because we still don't know any of the sides. Here, attack DB, attack the hypotenuse. Right? I'm going to use this triangle to find the hypotenuse of this triangle. And that'll be opposite and that'll be sine. Look at this. Sine 22 is equals to the opposite over the hypotenuse, right?
Mhm.
Again, the unknown is in the denominator, multiply both sides by the unknown. And then divide both sides by sine 22. So 8 divided by sine 22. That gives us dB, the hypotenuse is 21.36. Now what? Now if you look at our triangle on the inside, we have all three angles. This is 68, this is 31, this was 81. And now we also know this side length, 21.36. And we're trying to find CB.
Do you use sine law?
Yeah, exactly. You use sine law. So what over what equals what over what?
21.36 over sine 81.
Yes. That is equals to,
do you put CB on top?
yes, you do.
Over sine 31?
Yes, there we go. And what do we do on both sides to find the final answer?
You multiply by sine 31?
Correct. And that will give you the final answer, okay? So the approach here was to find the hypotenuse. So whenever there's multiple triangles, you want to attack the one side that both of them have in common. Right? You want to attack the one side that they both have in common. Here, let me show you a question. Now we can do like a 3D one. I don't know if you're ready for this, but I think you'll find it fun. Maybe, I don't know. Because the goal is to eventually, everything in life is going to be three-dimensional, right? You'll barely have anything in 2D. If I can find it, just bear with me. It's here somewhere. Yes, this question right here. Again, keep this in mind, okay? When you have multiple triangles, attack the side that both triangles have in common. So in this question, this is a 3D question, doesn't change a dime, doesn't change anything. We're trying to find H, the side length AC, okay? Which side do both of these triangles have in common? So we have two different triangles there. We have the triangle on the top, ACB, and then we have a triangle on the base. We can call that BCD. Now, which side length do both of them have in common?
CB.
Exactly. So let's attack CB. Let's start from the bottom. We're going to start from this triangle. I mean, two angles are given. If two angles are given, always find the third one. 63 minus 42. So this angle here, yeah, that is 75 degrees. All right, now let's find CB. How do we set this up?
You use sine law?
Correct. So what's the setup?
Um,
Whatever. Again, we're trying to find CB. So CB should be in the numerator, okay? And the angle opposite to CB is 42. What goes on the left-hand side of this equation? Again, we're just using the sine law in the bottom triangle. It'll be 68.5 over what?
sine 75?
Yeah, exactly. See, just like that. We've been doing this, okay? And then we're trying to find CB. We're going to multiply both sides by sine 42. Like that. You see that? So what does that give us? 68.5 divided by sine 75 times sine of 42. And CB is going to be 47.45. Now that we know what CB is, how do we find H? Look at the triangle on the top, triangle ACB. We know CB is 47.45. And again, that's a right angle triangle, right? Look at this. This bottom is 47.45. And this angle is 38. And we're trying to find this. So what do we use?
Use tan?
Yes. So tan of, what is this? Tan of 38 is equals to what over what? The H that's missing, the opposite, yeah? What's the adjacent?
47.45.
Correct, there we go, 47.45. And then you want to multiply both sides by 47.45 times tan 38. And then that gives you the height is like 37 meters approximately. So you will have multiple triangles. Whenever there's multiple triangles, you want to attack the side that they both have in common. Now let's do another one. Don't worry too much about these. I'm just trying to introduce you to the idea. Here, let's look at this. Same, we don't need to read any of the words. The diagram is sufficient. So in this one, we're again trying to find H. We're trying to find the height of the pole or whatever that is. Do you see two different triangles here? Which side do they both have in common? There's only one side they both have in common.
B and A?
Correct, BA. So you would first find from the bottom triangle, right? See, they're both right 90-degree triangles actually. So you can just use opposite, you can just use tan to find BA, yeah? And then once you have BA, we're looking for the yeah, then you'd use tan again to find H, right? And there you go. So even if it's like a 3D thing, the idea is very, very similar. Just attack the sides that they both have in common. Alrighty? All right, let's call it a day there for today.
All right, thank you.
Okay, bye-bye.